See how we do here. Hello, everybody in the cosmos. We are just getting connected, and Maureen is putting in a note. Hi, Ethan. You can hear me clearly. It's Lon. You should be able to. Let's see and make sure. Great. Roger. I like that. Roger. Good. That means. Okay. So everybody, four, three, two, at least. Good. Okay. And the power, everything's in my dock. Okay, so I can actually take a position and start to. Oh, that was fast. Uh, okay, so what I'd like to do is, in a moment, um, we will go to the PowerPoint uh, and the first slide, and then I'll come and I'll presenter you. I'm gonna present you, and then I'll deliver it. Let's do this here today. And then, if you could be at the board for the lecture, and then at some point during the lecture, while you're taking notes, I'm going to try and get somebody else to come. If Ron is here, I can't remember Ron. He was writing last week, the music student. Okay, okay. Well, he may be online, but okay, I'll get somebody else to. But that's good. So it'll be the first slide we will go to. And actually, you can put that up now. That's fine. Presenter view on that. Uh, and and that will be the middle panel. And then, okay, good. So we're getting very close to being fully set up. We have the map there. We were just running a little bit of a video. And just well, hold on. I just want to get my mind straight. 5 minutes before, and we are this well connected. Roger is definitely the name we should all be using today. We're all Rogers. Roger this, Roger that. Lovely. And then this will be middle panel. Yeah, so make that, that middle. Exactly. Exactly. Oh, that looks beautiful. That looks really good. And then I can deliver the lecture. Roger, Roger. Great. And we have not a bad turnout in the Cosmos as well. And then people are coming in person here, which is the best. Since we haven't officially started, let's keep running the videos. Would you be able to just go back and in the middle panel, bring back the video you were just running and just let it run for a little bit? Because I'm going to let you watch this all while we're getting fully set up. And for those of you in the Cosmos, you will see in the class 2 folder all the videos for today. So the one we're watching now is Scale of the Universe. And let's just let it good. Yeah, no audio is fine. How many of you here have seen this video before? Good. Okay. Not bad, huh? This video? Yeah, get you into the right frame of mind. Well, well, you know what? Let's have a little bit of get the music going too. We haven't officially started, and we'll keep this going. And uh, I'm just enjoying the moment that I can walk into a class now and have this machine really working well with Maureen and others here, and then I can just focus on all of you. Really, what make these classes just come alive so much. And come on in, Ron. We actually need you for the notes if you're ready, but that's coming. So I think we can officially begin. As we can see right now with this little creation from a couple of people online who make videos about the um, world around us, and we try to help us understand scale, I'd just like you to think about opening your mind to something very big today, because it's all going to be about the cosmos and about space and about how our planet Earth, shape. And this is going to require you to be ready to open your mind to something much larger. So this gives you a sense of scale that we on this planet are fairly small. We're learning, but that shouldn't be discouraging. It should be kind of inspiring, I hope. You're going to see today in this story a lot about our origins. Great. Well, why don't you can end the video and bring back Toria and the map and our DJ is running this whole thing. I cannot tell you what a pleasure it is after all of these years of building this to be able to finally not have to worry about that and just deal with this. And so, welcome everyone to Short History of the World, our second class of the semester. And today the story really begins. And we are going to cover essentially 13 billion years in the next 90 minutes or so in a combination of a little lecture that I'm going to give. Hopefully, I'll keep it to around 30 to 40 minutes. And then you're going to start to get the full power of this room because uh, teams are going to go to individual pods, and each team is going to be doing some research with a different creation myth. So each of you, each team is going to have a different creation myth to work with, whether it's a tribal or an indigenous creation myth, whether it's a religious creation myth. But creation mythology is a very important thing to think about because we can't talk about our origins on planet Earth. We can't talk about any of this unless we are ready to do something that I know all of you are ready to do this, but maybe you haven't had the chance in school yet. And that is to say, there is a bigger way of understanding how we got here and who we are. And it combines religions. It's inclusive, but it's bigger. It's the scientific story that we know of. But we still need to pay respect and understand that many other humans over the centuries and through many different societies have tried to understand something about our origins before there was science. So the Buddhist, the Hindu, the Christian, the Jew, the Muslim, the Mohawk, the Iroquois all have their creation myths. And you're going to be able to explore some of those today in your groups. But I'm going to help you understand the scientific story, the one where there's real evidence as best we can. That's the one that maybe some of you, even if you're super religious, are ready to deal with. And that is to say, maybe there isn't really just one God. Maybe there are multiple gods. Maybe there is no God, but there's something. Science is helping us to understand our origins. So before we get to that, is there anything you're good? Everything's good here. Everybody is in the cosmos. I just want to deal with the housekeeping a little bit, and then, and as always, to thank you all for coming in person like this because it's demonstrating to me that um, you want to have this in-person experience with other human beings instead of disappearing into your machines, which is what we tend to do today. And this is gives me hope, a lot of hope, as it should you. So the more you come in person like this, the more you're ready, the more I'm going to work my damnedest to bring you some great classes and some great lectures. It's it's a two-way street. So what I'd like to do first is make sure that we know who's on board, but we're going to do it very quickly. And then I'm going to start with the review and some feedback. And the review is going to be based on what you posted on the discussion board from class one. And so I want to always do that at the beginning of every class and spend 10 minutes or so at the beginning before I jump into the lecture. And then by hopefully noon or so, or 12:10, we can get you to the pods. You can be working on your individual topics, and everything that you're writing up there. We have styluses for each of you. All that you're going to be writing up there will be seen up here too, and that's when you're going to really see this sense of a think tank, a real think tank working. And so before we start the review, could you please go to the discussion board for class two? And I would like to actually, I've identified about 3 discussion posts that I think are interesting, but I have to say there was an embarrassment of riches, um, and it would be class two. Oh, class one. Yeah, she's good. You're ahead of me. Okay. So this is the part of the class where I get to see what you're thinking. And so please do not underestimate these little discussion posts week to week. They're only worth 1.5% of your overall grade each week. They're easy to get if you come to the class in person. But more than that, it's a way for me to stay engaged with your minds week to week so I can see if you're really thinking about what we're doing in this class. There was an embarrassment of riches in this first discussion board for class one. A lot of you, particularly all of you in the cosmos out there, wherever you are, not in person, were posting some pretty good, not just questions, but explanations of the questions, the 175 to 200 words. I was really happy to see that. The discussion board every class is where we see all of you together, the only time, so it's really where we get to see all the brains in the class from the cosmos, from Earth here. And so I would like to just read out loud maybe 2 or 3 of them, just to give a sense of what I think is interesting, and also answer the questions. Now, if you have any questions from last week that you'd like to address right now, please do so. Just we'll give you the microphone, but we're in the review section right now. We haven't started where we begin, the big part of the story today. I'm going to get to that in my lecture. But if you don't have any questions, and in the cosmos, if there's nobody who wants to put something in the live chat, I'm going to say, why don't we start with our resident scribe here, who was pretty thoughtful last week, and we had a default going last weekend. He didn't post his question until I think it was just yesterday, right? So as a guy who was here last week, he could have had his 3 out of 3 quickly if he put his question in, but he waited and waited. And then last night he went on and he posted his question. I don't know how he remembered what had been done the week before. Maybe he checked the recording, but that didn't really matter to me. The fact is, Ron's question: why are we more scared to love each other than hurt one another? Well, we don't know if that's true yet. You haven't seen the story of humanity yet, but based on what we covered last week, Ron was inspired to write that question. I'd just like to ask him to explain a little bit now about why he would write that question, because actually he's kind of on to something about humanity. And you're going to see through our story, it's not just about how humankind or mankind, we humans, came to this planet and rose and became dominant. Humanity means more than just all of us. It also means a state of being, the bond. And I have a sense Ron was picking up on something about maybe we're losing our humanity today or something. Go ahead, Ron.
I thought none of those things,
Oh,
to be
okay.
fairly honest. Um,
Go ahead.
I had to write this question with the necessity of painting humanity in a monolithic black and white way, even though I'm aware that each individual, they're far more complex than the paradigms of love and hurt and fear and acceptance and all that. But I only wrote that question because it's something I've carried with me throughout my entire life. Um, through the experiences that I've had that I won't really divulge.
Okay.
Um, that's why, I felt that it was a fair enough discussion to, question rather, to spring off discussion with other heads.
It's great you wrote that, and thank you for the explanation. And I would say to Ron right now that it's great that you're going from your own life and writing that, but in this class you're going to step out of your life and you're going to start to understand a kind of a shared human story that we all have in one way or another. And so we are going to see, particularly as we look at the rise of civilizations and what it was like to be alive at different times in history, whether fear has been with us for too long, and whether love and hope and optimism may be something humans aren't so good at. And I'm going to introduce you to one thing as a way of answering Ron's question about why are we more scared to love each other than hurt one another? Well, it's because, and you're going to see this next week when we start looking at the rise of civilizations and the God King and the rulers, the first rulers. And I'm going to bring in a very great world historian for you to understand, William McNeill and his son, John McNeill. They're two of our most important thinkers on this. And it is William McNeill who has told us about how we humans, very early in our societies, became slaves of the gods. So we chose slavery. We chose fear. Democracy and freedom and human rights and these things around, being more open, we've had to learn. We're naturally, deeply, but I'm not going to say biologically, afraid. And when you're afraid, it's hard to love. When you're afraid, it's easier to hurt. Think about it. So I'm just touching on this now. You're going to see this, but I thought that Ron was starting to go in a very interesting direction about hurt and love and big things around what it's like to be a human. And that's why you're in this class. You want to understand these things more. What does it mean to be a human? What do humans bring to the table that machines don't? That's the time we live in right now. So I'm going to try and help you understand by going back in time what exactly is unique about us humans and what we bring to the table that no machine can, no algorithm can. And as much as all the techies who are going to be standing beside Donald Trump in the inauguration next week, Elon Musk paid $277 million of his own money to get Donald Trump elected. 277 million. That's why Elon Musk is going to be the head of government efficiency. All these techies, the billionaires, the tech billionaires that will be standing beside Donald Trump at his inauguration will all be telling you machines can replace humans. And guess who's going to make the money from that? Not you. So just be aware. You're living at a very, very interesting time in history right now. And we need to go back and understand a lot of things. So let's go to one more. Is May Rodrigo? May Rodrigo, are you in the cosmos today? Or are you somewhere else? You're
Yeah,
traveling in another part of the galaxy today. I think May
yes,
is
I
somewhere.
am here.
Okay, but let's see. Is she? Well, we'll leave it for now. Okay. So this is what May has written. And May, if you're in the cosmos right now and we're reading this out loud, please jump in and say hello on your microphone or in the live chat. But I just want to read this out loud and then we're going to move on. This is a student who got her three full marks, even though she was not part of the in-person class. She gave the reason for her question. My question is, what role does the spiritual aspect or religion play in humanity's relationship with the Earth's creation? Nice. The reason why I asked this question is that different cultures have their diversity of spiritual approaches on the Earth. Exactly what we're going to be exploring today. I wonder how to understand the creation of the planet without the superpower that comes from above. I mean, comes from the most superpower forces that are unimaginable. That immediately made me think this is real. This is written by May, not a machine. Okay, because this is always my dilemma when I read anything you write now is did you go to ChatGPT and just throw it up there at 11:58 p.m. a minute before the deadline, or am I actually getting you the real you? And when she wrote these two lines, it's a bit repetitious, a bit sort of expressive. It made me think this is not a machine. See, machines are perfect. Humans are imperfect. Okay, humans are out of the crooked timber of humanity. No straight thing was ever made. Okay, so we're not perfect, and as it should be, because in imperfection, there's always opportunity for growth. So, I mean, comes from the most superpower forces that are unimaginable. Being spiritual or religious, the creation of the earth was created by no human hand, as they believed, which shaped the earth's relationship. And how does religion play a role in shaping humanity on earth? I wonder what is the driving force of spirituality or religion in shaping all this, and also by science. I am looking forward to learning more about the evolution theory to enlighten my questions with regards to the Earth's creation and mankind. Humankind, may, but I probably don't need to tell you that, which I believe lately through stories or discoveries that have been found. That being said, the world's beginning. I want to know how the world was created and who. I believe there is more to tell. Just raise a hand and be honest. I'm not taking any mark. How many of you kind of wonder about the same things that May is wondering about? And if you don't care about these things, that's okay. All right. For those of you who didn't raise your hand, I just want to see if anybody's ready to tell us why. You don't, and this means you are going to be explaining something where a lot of people might disagree with you. Are you ready to do that this early in the class? It might not be. Jazeel, why don't you come up, okay? Jazeel's always ready and grab. Here we go. Okay, and so why are you not interested in the bigger story? There's maybe a bigger story to tell.
Well, it's not that I'm not interested. It's a question that we may or may not have an answer. Though it's not a correctly. Most religions are formed from ancient stories that becomes normal stories, legends, then myths, then turn into religion.
Yes.
Most, not everything. And some religions have a directive answer to its faith. Some can go way back as be the Abrahamic books, or even further.
Yes, they can.
Some maybe got twisted and would, turned into many things.
Huh.
As it's not that I'm not interested. It's mostly there's an answer and it's a theory. But
Okay, it's a theory. This is good. So you're bringing up. Keep standing there, okay? We're going to jump into the lecture shortly, okay? This is great. I always like to skate with the class. So when I walk in here, it's like, depending on where we go, I'm going to move right, left, center. I used to play a lot of hockey. I understand how it works, okay? So I'm going to skate with him for a little bit because this is good. Um, are you suggesting that we we really can't know how we got here? Like it's all just
No, we
theory?
could. We could. There's always a base behind religion. There's something like old warrior story, maybe a children's story that is created by the old people, old elders from a normal tribe. Anything could happen. Maybe
Hmm.
those were passed down through centuries, become centuries, millennia. Maybe that's how Greek gods came to be. We don't know.
We don't. But is it possible we do know through science?
Um, Probably, but we have no evidence of it.
Oh,
One,
oh, stop, stop. We got to stop. If it's okay. Not true. We do have evidence. I'm going to show you some evidence. Okay, now, excellent. Go. Can you, let's start, okay, just so we can stay on the lecture, but grab a seat, okay, and be ready. But thanks for, uh, yeah, right here. Yeah, go ahead. Jazeel was in another one of my classes, so he's comfortable doing this and putting his skates on, and he has sharp skates today. Isn't it the worst thing when you have dull skates and the ice has just been flooded and the Zambonis disappearing, and you come off the dressing room, you got your team, you go on in the ice, and the skates are dull. And the ice is all nice and flooded. That's one of the worst experiences you're going to have. Anyways, I'm going to talk maybe a little more about hockey these days because the Leafs are starting to win again, which is just somebody's got to explain what is wrong with Austin Matthews. Does he have a mental health issue that we don't know about? Is that what's keeping him off the ice? If he does, why doesn't he own it? Why doesn't he own it and say, yeah, I'm the big Toronto Maple Leaf, I'm the star, and I also struggle with all these anxiety issues and like everybody else. But apparently he just sort of, do we know what he has? It's always this mystery illness. Ryan, what does he have? Yeah, it's hard, isn't it? Especially when you're a big athlete. Yeah, big athletes. But you guys are changing things. You're the anyways, did everyone sign here before we? Okay, good. So you know it's here, all right? I want to spring off, take the puck from Jazeel, who bravely came up here and started to talk about what he thought and explain to you that today we're going to look at the beginnings and we're going to look at proof as best we have it, okay? So in the next half an hour or so, we're going to cover quickly about 13 billion years of history to get us up to a point where we, early humans in the form of primates, are going to diverge from our primate ancestors like chimpanzees and gorillas and bonobos and monkeys, and we're going to come down from the trees and we're going to start to walk. That happened about 7 million years ago. But there's a period in terms of origins to really understand it. You need to remember that. Oops, let me just bring the cursor back. I've got it here, and we're here. So just remember that the story that we're telling starts today with the very, very beginning. And there is a giant that I will be referring to from time to time who can help us today. And his name is David Christian. David Christian is the originator of a whole field of history called Big History. And you can even take a course here called Big History. But Big History is part of something even more that I'm going to try and help you to understand. But he's a real pioneer in helping us to think about the story of humanity going all the way back to the very beginnings. And this is his classic book, Maps of Time, where he talks about how we got here from a scientific perspective. And he's a very important thinker in this field. So you can take a look at that and pass that around. But I always want to remind you that every week there's going to be a giant on whose shoulders we stand. It's a cliche. Many important thinkers have used that. Charles Darwin talked about that. Isaac Newton talked about, the other giants. So in the story that I've created for you from my research, it's based on a lot of scholarship and a lot of important giants who have already paved the way, like Jacob Bronowski. You remember Jacob Bronowski from last week? A wonderful thinker who talked about the idea that there's a coming of a new mind. He wrote The Ascent of Man, the original Neil deGrasse Tyson, and we looked at Earthrise and that whole period where we start to see the planet as one. You remember that from last week? So these are the guys, David Christian, and there are women too. Cynthia Stokes Brown, I brought her big history book as well. I have many of them, read them. And they are really paving the way for human beings to begin to deal with this idea that since the 1960s, since we began to see the planet as one whole thing, and it's no conspiracy, it's real. We went on the Apollo missions. The Earth is definitely around, okay? There are people online who will, for attention, they're going to tell you all sorts of crazy things, but that's called pseudoscience. And Maureen, could you just write this word down? We're going to put a few words down today, and then we'll get a student to start writing. We don't have time for pseudoscience in this class. We want the real thing. Pseudo means fake science. And science, when it is mixed up with ideology and people who already have beliefs, they tend to twist science into what they want you to know. Real science is when a person is discovering something and they didn't know and they can prove it. And that's what I'm going to present to you today. So here is the most important question that we can ask. And you stopped asking this when you were a child. Maybe you are asking it secretly. You're a secret philosopher, I hope. But this is a great question to ask. Where do we really come from? Now, in a moment, I'm going to show you a simulation from the Massachusetts Institute of Technology using a very powerful computer to help show you what we believe happened around 13.7 billion years ago. It's called the Big Bang. But before I do that, I just want to remind you that this is the scientific creation myth, in the sense that science can show us many things, but science still does not know many things, okay? Science is a process of trying to understand what's really happening in nature, like and using our critical thinking and the rules of evidence to prove that it happened. For those of you who have trouble with this and think science is the answer to everything, it isn't, but it's the best we have. When you do your activity, you're going to explore all the different creation myths, and there's some beautiful poetic myths, even the scriptures. To give you one example that's very common, the Bible, the Holy Scriptures. The Bible, not of the Sikh, and not of the Hindu, and not of the Buddhist, or the Zoroastrian. Remember, there's a lot of different religions. We're not even getting into indigenous cultures, but the Bible of the Muslim, the Jew, and the Christian. Lots of Christians here. All those three great world faiths, they're called the Abrahamic religions because they all share the belief that Abraham is their guiding prophet, their most important. Well, we could debate that, but Abraham is critical. Most importantly, they all believe in one God. You're going to see, as we start to pull back and really look at this larger planet-wide story that incorporates all of humanity in the history of what has been happening on planet Earth,
that actually God is a creation of the human imagination. And just to be able to drive that home for you before we get to the simulation, we're going to spend a good chunk of time on Greece and Rome. Of course we will. Greco-Roman civilization, where the Western world began to grow, and all the guys here are going to hear about the warriors and the emperors and the fighters and, the great philosophers and battles. And those two societies were pagan. In other words, pagan, I'm using a term that's not even fair to use, because pagan is a kind of a Christian term. But anyways, before Rome adopted Christianity as its faith and then established Christendom as the great European faith, there was no one God. There were revolutionaries and others like Jesus and Muhammad and Moses who were trying to say there is. But Greece and Rome, they grew into the great powers, the great empires that they were, on the idea of multiple gods. And then I could go and talk to a Hindu right now or a Sikh in here, and they're going to say to me, of course there are multiple gods. Yeah, there's maybe one, but there are many different gods. So get your mind around the fact that when we talk about where we come from, there's a diversity of ways of thinking about it. And that's what you're going to be really learning more today, that diversity of ways. That doesn't mean that your religion or your way of looking at things is being disrespected in any way. What it does mean is maybe we humans really don't know yet. Maybe we humans just got here. And that's actually kind of true. Here we are in 2025, and we have only had civilization on planet Earth for around 10,000 years. From the standpoint of how things have been developing on this planet, where we connect ourselves to all the other things that have been happening, 10,000 years is kind of like yesterday. We're going back to 13.7 billion years today. We're trying to get the totality of our existence. And that's what David Christian really tries to help us to understand is, what is the totality? Well, let's watch a little video, okay? Maybe could you come in? For those of you online right now and in the Cosmos, please click in the Class 2 folder on what's called Illustrious Simulation. And in a moment, we're going to run this video. You can watch this on your own at home. Right now, it's a 5 to 6 minute video, and we'll have the audio and everything, might even dim the lights. A group of physicists and cosmologists and scientists at the Massachusetts Institute of Technology, which is a leading academic institution, kind of like Ontario Tech, but maybe a little bit more developed, a little bigger. I'll try not to use American examples all the time, but because we're in a fight with the US right now, and a lot of Canadians just want to just destroy Donald Trump, and we're in a fight. And we might be nice in Canada, but when we get pushed, we fight hard. So get ready. So I'm not that interested in talking about the United States right now. However, there's a big part of the United States that is very still following the American spirit of openness and inclusiveness and no walls. And they're the great scientists. And all the Nobel laureates this year in economics, physics, and health, they're all American. They come from American universities. There's so much inventiveness and growth there. So at MIT, it's a great institution, as you know. And there's a group there that put together this simulation. They took hundreds of thousands of numbers, crunched it into their computer, and came up with a picture of what they think happened at the beginning. Essentially, when something came out of nothing. Try to get your mind around this for a moment, okay? Something came out of nothing. It's impossible to think of nothing because we want to think of something. But even Albert Einstein said that behind that beginning that we know of when we started to have matter and gases form, there must have been something. We just haven't seen it yet. We will. We're going to discover it. So this beginning that I'm showing you right now is the beginning to the best of our scientific knowledge today. That's it, okay? But we will continue to know more. Great. I'll explain. Let's watch this and we'll talk about it after. Go ahead and we'll run the audio too. Oh yeah, you might have to. Yeah, sorry, go back. I can. There we go. That's good. Yeah. Oh, ooh, where's our video? Ooh, you may be missing our video. Ooh. We just need some video to go with the audio. Yeah, there we go. Good. Okay, now go ahead. They should run. Yeah, great. Okay. We'll talk after about what you're seeing. Take a look on the bottom. There's been a bang of something, and gas, hydrogen and helium have started to be pulled together by gravity. Evolution has begun. Radiation, heat, and light. In the bottom right-hand corner, you see redshift. That's very important. That's evidence. I'll explain afterwards. Redshift. Something has come out of nothing, and it's gas. Very, very slow. 10 billion years now have passed. Like watching paint dry forever. But this is sped up. Okay, here we go. The coalescing, coming together. Gravity is pulling it. Gravity is really pulling. It's a force. Electromagnetism is a force too. Gravity is the force that pulls it all together. It's pulling the gas together. It's going to create stars. Stars are going to create soon planets. Metallicity. Metals are going to start to be created in this. The darkness is being lit up. Now the stars, millions and millions of stars are just gas. That's all stars are. Gas. Stars come together into galaxies. Good. The simulation is almost no difference. Dark matter, we're just learning about it now. But 80% of what's out there, we don't even know yet. Dark matter. The heat of that gas is like the heat of the sun. We're talking about millions and millions of degrees Celsius. That's radiation, heat, and light. So much we know, so much we don't know. Dark matter. But this we know. Stars are formed from gas. Stars come together into galaxies. And we're just one galaxy, one star. You will see shortly. I want to leave the credits up for a moment. I want you to see who is involved. This is real science. This is not Lon making something up for his students in the middle of the night. This is not pseudoscience. I'm afraid I have to say that. Because if you go online today, it's just swimming with pseudoscience. And we got to fight against that hard. Otherwise, everybody's going to get really stupid in this world and they will believe anything. They won't know anymore what to believe. Now, when we look at the people who are involved with this, you will see there's some very good institutions and scholars, but let's move this along, okay? And I'm going to come back to, hold on, I think I can do this. Maureen, I'm just going to bring my laptop back for a second, just the presenter view, okay? Thanks. We're going to continue, but I want to just stop and make sure you understand what you just saw because I was talking a little bit and you just saw the best science that we have of how it all started. Well, what did you just see? And why does it matter? I'm going to tell you something that will blow your mind in a moment, but that's my job. I'm here to blow your minds, get you interested. Does anyone have any questions? Anything? We'll go to the live chat if you can, and we'll see. Something came out of nothing. Those gases began to form. We don't know why exactly. We just know it happened. Now, redshift is the critical evidence here. Redshift is what happens when light, as it travels and travels, it begins to dim and it starts to get redder. And so the actual timeline of that this light, these gases began to form 13.7 billion years ago and then began to travel through space at the speed of light, which is 250,000 kilometers per second. The photons of light, those things have been traveling and they're still traveling through space. But we can date that light because of the way the redness in it has formed. Does that make sense? It's really important you understand this part of it because as Jerry Coyne will tell us, he's an evolutionary biologist at the University of Chicago. He's written a great book called Why Evolution is True. And he tells a wonderful story about how when he was speaking to a group of executives in the United States, and he was telling them about evolution, a man came up to him afterwards and said, "I know what you're saying is true, but I still don't believe it." You see, a lot of us, or some of us, have an emotional block. We just can't open our minds to the fact that it could be something other than what we've been told all our lives. Or we just can't believe that we, humans, if you go back enough in time, come from particles of, of neutrons and protons and electrons, that the same things that form stars and atoms. We come from that stuff. No way. It's not what God says. So imagine an intelligent human being coming up to a top evolutionary biologist and saying to him, "Liked your presentation. Yes, Charles Darwin and Alfred Russell Wallace and all the evolutionary thinkers who've helped us to see that they're right. There is this thing called evolution, and the story is really bizarre in terms of how it's all been unfolding. But I still do not believe you." So this might come as a shock to some of you, but at any rate, I'm going to try and present you with the best science we have. 4.5 billion years ago, approximately, let's say 5, okay, and we'll start a timeline. And to give Mayreen time to do her other work, this is where we need to get our scribe back on, and I'm going to even sweeten the pot today. I was ready with Ron this week. Had he not posted his question, I was going to give him 3 out of 3 anyways for the work he did last week and going up there. And if any of you would like the easiest participation mark, here's all you have to do is you have to stand up, you have to walk over there, take a pen, and start writing. And you don't have to do your question. If there's nobody who wants to do that, and I've bribed you as best I can, then I'm going to ask Ron to go back and write. But Ron, please go ahead, and you got your 3. But you can always put more questions in, and I'll try to find a way to give you more marks, but I really can't. So let's start the timeline. The timeline. Ron, could you just write down timeline and then 5 BYA, 5 billion years ago. 5 BYA. What we're doing right now is we're doing a real-time PowerPoint. Instead of you falling asleep with yet another PowerPoint that I have to sit through in a dark room, and I call that my education, you're actually, some of you, are watching what Ron writes. Yeah, well, that's because you should. That's a human being writing. And you're going to see soon in civilization that when we began to write, we gained a great power. So if any of you have trouble writing, as I said last week, and I'll say it again, please come talk to me, because your ability to write is critical to you being a successful, intelligent human being on planet Earth. If you have a disability, no problem. We can help. But if you hate writing, I've got news for you. It's time. You're going to have to learn to be a little bit more like Ron. 5 BYA. Solar system takes shape. What do we have? Well, we have that gas, the hydrogen and helium, number 1 and number 2 on the periodic table of elements. Hydrogen and helium, gas. What's that? Lovely, exactly. Thank you. Nuclear fusion happening. You know what nuclear fusion is? It's when you have the particles, protons and neutrons. It's so hot that these atoms or subatomic particles clash together and they fuse into one. That's called fusion. Nuclear. Nuclear is nuclear inside, middle of the sun. It's this fusion. When we have the atomic bomb in the Second World War with Albert Einstein, we talked about that last week. That was nuclear fission. That's the splitting of the atom. So we humans will figure all this out later. There are no humans for billions of years yet. This is just nature. But thank you for that. This is nuclear fusion that took place. That star is just a big ball of extremely hot gas. And the gas in the interior of it, it's about 150 times the size of Earth. I think it's something like 10 million degrees Celsius. The nuclear fusion has created such heat and such light that's enabled another process to happen all around it. The sun is just one star of billions of stars, and we humans barely know any of them yet. So I wish we would be alive in even just 100 years. If you want a new career, go into nuclear research where you can start to work with how can we harness the power of nuclear fusion and create clean energy for humanity and get rid of all the fossil fuels. That's the next maybe big thing in energy, is how we get nuclear fusion down here on Earth, and we can get energy to everybody for free. No more corporations, no more wars based on fighting over the sun. About 4 billion years ago, we see a cooling down through this time over billions of years that you saw, very sped up in the MIT video, where things start to stabilize. For a long, long time, things were moving and clashing, and gradually gravity, which is the great force, gravity is pulling things together. So gradually, the sun took its place, and then there's the Earth and the Moon, and there's Mercury, Venus, Earth, Mars, Saturn, Jupiter, and they're all pulling on each other with gravity. The sun is pulling on the planets with gravity, and the planets are pulling on the sun. And through this kind of great cosmic ballet, as it's often called, gravity helped to stabilize everything. For now, something quite remarkable to take place. This is called our solar system. The sun is the battery of everything that has happened. If you look at the way things are arranged here, you will notice something unique about Earth's position in all of this. And some of you may know this term. Do you know the term of what makes Earth special, not too hot, not too cold? Do you know what the scientific term is, Ron? Are you too sleepy? Okay, good. So who knows? The Goldilocks zone. Could you please write that down, Ron? Goldilocks zone. Notice Mercury, tiny, tiny rock, super, super hot, because it's the closest to the sun. Venus, and you got Earth, third rock from the sun, and then Mars. Well, Earth happens to be in just the right position where it's not too hot and not too cold. And scientists call this the Goldilocks zone. Not too hot, not too cold. The oatmeal, the three bears, the story of the three bears, the children's story. Not too hot, not too cold. So we got lucky. But hold on, we're still very early on, but the Goldilocks zone, exactly. I'm going to start to speed this up a little bit, okay? About, oops, I'll just bring this back. The cursor is, hold on. There we go. Good. About 3 billion years ago, this incredible planet began to display unique signs of activity that no other planet in our solar system has, as far as we know. We are starting to think that Mars might have had some of this. And then because it doesn't have a proper protection from the sun's radiation the way we do with a magnetic field, it got burnt. Everything got destroyed. We think. We're not sure. We're not sure. Hold the question. I just want to make sure I deliver this today. Okay, Ryan's here. He's from another class, and I've loved when he comes because he has good questions. But I want him to hold the question. But I will take a question from a student who's registered. Okay, but I want to stick to my time today. But go ahead. Okay, you're going to have lots of time to work on this the pods. But I'm fine with questions as long as I can bring it back. Okay, and go ahead.
Why do people think that there's life on Mars, or there was?
We have started to discover through the rovers and other little machines that are now up there doing research that there's some evidence that there was some water on Mars. And there is some speculation now among scientists that this may indicate that Mars once did have life on it. Because it doesn't have the kind of iron core that Earth has, our iron core gives us a magnetic field. That magnetic field around Earth protects us from the sun's radiation. It's believed that because Mars doesn't have the same, the sun may have burned all the life away over time. But it's total speculation. We're yes. Yes. I'm going to say that's a great question. And I'm going to even say, more than that for a human being to ask that question and say maybe there's some form of life or some form, and I'm going to explain what life is in a moment, you're going to see that is not carbon-based, takes a certain leap of imagination that you're prepared to even think about that. We don't know. However, let's take a look. Just hold it, okay? Let's take a look at this special planet. We're now at about 3 billion years ago. So let's just, all that we've just seen in a very introductory way started 13.7 billion years ago, and now we're at 3 billion years ago. Well, because of the sun and because of water that existed on planet Earth over time, this, let's call it what it is, this miracle happened. I am a person who is passionate about science, as you know, but you might be surprised at how spiritual and religious I can get, too, when you really start to ask bigger questions like, how is it possible that the sun and the water created a cell? Because that's what happened. And that's what you're looking at right now. It's called a prokaryote. Now, does anyone want to try and spell that? There are people here who can. I'll help you. But this is important. And when I used to do quizzes in this class, I would put prokaryote on it. But it's just a little bit of information. You need to know the big stuff. So I've got rid of the quizzes and the tests and deal with the ideas. Okay, that's what you're looking at, the big ideas in this class. But it would be good for you to try and remember this, or it's in the notes. Prokaryote. Thank you. Maureen is on it. I'm going to just put myself out on a limb and join one of my other heroes named Václav Havel, the former president of Czechoslovakia in the 20th century, who spent a lot of time in jail fighting for his beliefs against the Soviet Union and came out and survived, like Nelson Mandela, a great writer. And he said that when you really start to understand this story, it's a miracle. And he's a science guy too. We don't know why the prokaryote happened on Earth and it never happened anywhere else. We know what happened. We know that the heat from the sun, not too hot, not too cold, and the water, not too deep, not too shallow on the planet. And in that, things started to happen. And the prokaryote, the single cell, became a eukaryote. Multiple cells. How do you think that's spelled, Ron? EU? And then keep going, okay? Notice what's happening in nature. You have a clumping together. This is very, very interesting force. Think of the dust underneath your bed. It starts with a little bit here, but over time, you go to the bed a month later, if you haven't cleaned it, which you probably haven't, and that dust ball has gotten bigger and bigger. I don't think it's your cat or your dog or the mice or the cockroaches and the other animals that made that happen. Maybe it's some, I don't know, air, but it's also gravity has a way of pulling everything together. In the way that it pulled together the gases at the beginning, gravity was helping to pull together the cells. All these little prokaryotes were swimming around. This is going to become the basis of our DNA. Our genome is all now happening. These single cells clump together into multiple cells. That's eukaryotes. And this is now the motor of evolution that's taking place, because then we start to see around 2 million years ago, Ron, we see our first forms of kind of life, real life happening in the water. That's algae. 2 billion, 2 BYA. And you can always refer to 2 BYA, 2 billion years ago. Algae. Boy, if you've ever looked at how algae reproduces, you will start to understand something about its power. Algae reproduces at a massive rate. It doesn't respond to stimuli quite yet. It sort of has a metabolism inside of it, and it is growing, but it's starting to distinguish some of the elements of life that are going to distinguish you, trees, dolphins, chimpanzees, dinosaurs, and all the other creatures on this planet, which is they have the ability to grow, um, to reproduce. They have an internal metabolism that is based on the cell. All of everything in your body has cells, bone cells, brain cells, blood cells, billions of cells. Life has happened on planet Earth and nowhere else. And I'm going to jump ahead now to 500 million years ago. But I want to remind you that when we begin to look at this story of humanity on planet Earth, we have to understand nature. We come from nature. We've grown out of this. The human brain is the most sophisticated, developed thing that has come over billions of years of evolution. You're living at a time right now where the techies, the Jeff Bezoses and the Elon Musks and all the big techie guys, they think we can duplicate the human brain. We call it a neural network. And we can just build it fast, and it will do what the human brain does. Do you know how many billions of years it took for the human brain to be created? And we humans think we can do it that quickly? Maybe, but just maybe relax here a little bit. Evolution has had an enormous time over, and many things have died and been extinctions, and gradually this is what happened. 500 million years ago, you're looking at a special place in Canada. I went there with my wife. It's at the furthest tip of Newfoundland, and it's called Mistaken Point. It's soon to become a UNESCO site. That's us a few years ago on a trail out there, the Atlantic Ocean around us, right at the edge of Newfoundland, because we've come to see something special. That's our guide who showed us this thing there. This is the beginning of the creatures called the trilobites. Could you write this down? The trilobite. Trilobites. Now, what are we looking at here? Well, what we're going to look at is that This process that began with prokaryotes and eukaryotes that then start to develop these strange things that are happening in the water, like algae and jellyfish and other things, this is going to start to diversify and create all these new forms. It's called the diversification of life. We know it happened. We don't know exactly why. So we'll leave that for the gods. Why would there be so much diversity on planet Earth? This is the remarkable thing. This should be a wondrous thing for all of us, not to be afraid of. That diversity is in nature, because here we see the beginning of a creature that starts to stand. That's my hand. And that's what's called a fossil. And that's rock. And this is evidence. Let's understand this, okay? That rock, we know, is about 500 million years old. Do you know why we know that? It's not because the rock has carbon. That's living things. We can date living things by the degradation of carbon in it. But carbon does not exist in inanimate things, in hard things. But there's something that does that we can date too. Do you know what that is? It's a natural element. Uranium. So we know that that rock is about 500 million years old. And we know that there was a shape of something once that was in that particular spot. That's called a fossil. A fossil is not a skeleton. A fossil is not something, like a bone or whatever. A fossil is a print of something. So once upon a time, on that rock, there was something with that shape. And then over time, it died. And then the sediment built up over that rock over time. Tectonic forces moved that rock so that it eventually became a cliff, because we have what's called tectonic plates shifting in the planet. As you know, if you look at the Americas and you look at the map of the world, you see the Americas and you see the Atlantic Ocean and then you see Eurasia. Yes, you're right. It all was together at one point, like a puzzle. But the plates move, and it takes about 250 million years for the plates to move all to the edges, and then they all move back every 500 million years. They go this way and that way, this way and that way. We are right now in about of a midpoint, 200 million years since the last time when it was together. In about 50 million years, we will be far apart. We're going to start to move back together again, unless we change that force. We humans probably will. So a fossil is something that was there. It got buried. It disappeared. Its shape disappeared, but the print of it, the shape of it remained. Does that make sense? That's how we date things. In the layers of the planet, we find all of these fossils and things and all these weird shapes going down deeper and deeper into the planet. And we know that that rock is 300 million years, 400 million years, 500 million years. And yet in those rocks, we're seeing all these different fossils and shapes. This is how people like Charles Darwin, Alfred Russel Wallace, Jerry Coyne, evolutionary biologists are going to start to say to us, wait a minute. There's been some stuff going on here in the planet, and how is this all connected? It isn't just God who put everybody here. Things have been going on, changing over time. Is this making sense? Fossils? Well, there's a trilobite. And here's another one. Look at that. Look at the shape of what's starting to happen. Why? We don't know. We just know how these creatures are starting to develop hard shells, become like our spines. Some of those creatures are going to do something remarkable. And I'm going to show you a little video in a moment. We are now at about, we are still at around 300 million years ago, okay? 300 million years ago. on planet, there's been a plant. Things are starting to grow. And the creatures that lived in the water, some of them are going to come out of the water. Now, you may ask yourself, why would they do that? Well, we have a term for that. It's called an amphibian. An amphibian lives half in water and half on land. Well, about 300 million years ago, approximately, this is what happened. Life began in water. But some of these creatures will come out of the water, and they're going to grow into us. Now, if you don't believe me, I want to show you something kind of pretty amazing. For those of you online right now, please go to the octopus video. And I think I've called it Mutant, or it's the next video. Ethan, in the class 2 folder, what follows the video, the illustrious video? It should be, is it octopus? Mutant? Okay, Cosmos is quiet. That's okay. Guys, in the cosmos, wherever you are, just watch the octopus. It's called, I think, Mutant. Could you tee up Mutant? And I'll start by telling you this. You can just freeze for a second. Yeah, great. For many years now, when I've been coming to teach here, I get on the subway at either Keele or Dundas West in Toronto. And there is a pigeon that has been coming on the subway with us all this time. This pigeon stands on the platform at Keele or Dundas West quietly while others are there. It waits. And when the subway rolls in, people see the pigeon there and they make room for the pigeon. It gets on. Pigeon comes onto the subway. And then gradually at Ossington or Bathurst or Christie or whatever, never really know, the pigeon gets off. Why would a pigeon be in a subway station? Why would a pigeon get on a subway? How did the pigeon figure out that you stand on the platform and you wait? Because the pigeon is a mutant. Now, that's my way of setting up this video. There are many, many intelligent creatures among us, and we are not those creatures. There are many other creatures on this planet that know what's going on too, not to our extent, but all those birds sitting on a wire above the street, and then they all fly off together and they all come back and they look down, or the crows that are crying out to each other, or the pigeons, or octopuses or octopi. They understand things in their own way. This video, go ahead and run this video, and I'll narrate it for a moment. This is an octopus that was filmed at a just lower. Oh, okay, I think it's okay. An octopus is not supposed to come out of water, correct? Generally, but this one does. And these tourists at a marine park in California were so amazed, they put this up on YouTube. This octopus is doing what octopuses don't normally do. Why is he doing this? Or she? You don't have to answer that. The point is, you have to accept that in nature, there is a thing called mutation. We are mutants. You will see. You can stop and just leave it up there. That's great. Okay. Come back to here. Yeah, good. Just leave that up here for a moment, okay? Thanks, Mary. The reason things change on the planet is something we haven't figured out. They just do. They mutate. If you get octopi or pigeons doing the same thing generation after generation and passing on the knowledge of how they do that in their genome, eventually, one of those is going to have a slightly different genetic setup or genome, and they're going to do something different. That's called mutation. And if that thing that's different allows them to survive, they're going to keep doing it. And they're going to pass on that knowledge in their genes to the next generation. Does that make sense? Are you understanding? This is evolution. This is what we are a part of. We are a result of this. Now, octopi mutated. Many creatures mutated. And eventually, on planet Earth, now we're at about 200 million years. Huge creatures begin to emerge on the planet. We found them in the rocks. That is a fossil of a dinosaur. 5 meters, its foot. If you took a measurement of its foot, because we find footprints now all the time in mud that's well preserved, the diameter of the foot is 5 feet. The weight of this thing was about 45 tons. You know why there were huge creatures that began to emerge on planet Earth? It has a scientific explanation. Oxygen. There is a thing called photosynthesis, a natural process. When those things, life, began to take shape, eukaryotes, prokaryotes, and then gradually these larger creatures, they started to put more oxygen into the atmosphere. But most importantly, when trees and vegetation and what we call the fauna of the world, because there's the flora, those are the animals, and there's the fauna. The flora is the plants, the fauna are the animals. So those are 2 kingdoms of life. And with the flora, in order for those flora to survive, the trees and other things, they get their power from the sun. It's called photosynthesis. They get their energy from the sun. They metabolize. And as they metabolize, a byproduct of photosynthesis is oxygen. So the more fauna, the more flora you get on the planet, the more oxygen there is in the atmosphere. And the more oxygen there is in the atmosphere, the more oxygen there is for things to breathe in, the larger those creatures get. Does that make sense? Am I losing you? Because this is important. This is evolution. This is how we're going to grow. We come from all of, we share a close genetic bond with all these living things. All these living things have cells in them. And we've learned that they all have genomes. A genome is where we have all of our genes. There are 25,000 genes that we humans have. Well, all creatures, including the octopus, they have their genomes. We share genes. 98% of our genes are in a chimpanzee. The only difference between us and chimpanzees is 2% of our genome. Pretty powerful 2%. For the sake of time, I'm going to move quickly because I really want to and I'm not going to run a next video, but I want you to watch this on your own. It's a remarkable video that was discovered in a market in Myanmar of a dinosaur feather, tail. Dinosaurs once had feathers. They had tails. And in a piece of amber preserves things really, really well. We have the remains of I have to show you this and then I'm going to stop. I'll just be a little behind. You must see this. 99 million year old dinosaur feathered tail is going to make you feel like you're looking at the tail of your dog or cat. And it's going to be weird because you're going to have to remind yourself you're looking at a 99 million year old dinosaur. And you're going to say, wait, dinosaurs had feathers? Okay. Maureen, would you be able to run Dinosaur Feather? Then I'll stop, okay? I'm just a little bit behind today, but we're okay. For all of you online, go ahead and watch. This is just a 2-minute video. One of the most beautiful and remarkable things you're ever going to see. Feathered dinosaur discovered by a team at University of Saskatchewan. Dinosaur with hair. You have hair. Did you know that there was a branch of dinosaurs that eventually had bigger feathers that became wings? Have you ever thought that when you look up in the sky and you see birds, that they were once dinosaurs? Does anyone want to say impossible? You're making this up, Lon. The birds were just put there. God's dominion. The birds here, and we got the rats here, and we got the humans here, and it was all just a. No. In fact, dinosaur was a much more complicated creature, and there we go. All those things flying around once were large dinosaurs, or just a branch of dinosaurs. Now, I'm a little bit behind, and I am way behind in terms of wanting to get you into an activity. I apologize for that. Why don't I just blow through 4 slides really fast to make sure I've got you to the right timeline, and then we'll stop, okay? 60 million years ago, Ron, in the Yucatan Peninsula, if you look at Mexico on the map right now, you orient yourself to Central America, and you look at the Gulf of Mexico, and you'll see a little spit going out, the Yucatan Peninsula, a giant sort of object from outer space, an asteroid about the size of Toronto, and a few other small towns and villages, collided with the planet. It led to a period of great climate change, very fast, and the dinosaurs could not adapt. It's called the Great Extinction of the Dinosaurs. But there were creatures who were living and coexisting with the dinosaurs. They're the beginning of us, the mammals. Little creatures who lived in sort of holes and away from dinosaurs, and they would only come out at night. The dinosaurs were sleeping, and gradually, when the dinosaurs were all gone, they started to really populate the planet. And over time, they will evolve their shapes too, over millions of years. And we will start to see, particularly in the eastern part of Africa, if you look at Africa and you go down the eastern coast, you start in Egypt, and you go down to Ethiopia, Sudan, Somalia, the Great Rift Valley, it's called. There is where the land used to be very, very lush. And it had the right sort of features. And these creatures who emerged there and took their shape, our primate ancestors, they were living among the trees. And over time, from 60 million years, 50 million years, 40 million years ago, we're coming now to about 7 million years ago, Ron. We have this diversification of different creatures, different shapes, different sizes, but they're all quadrupeds walking on fours in the trees. But then there's going to be one of them that's going to mutate. For whatever reason, it starts to come down from the trees. We could explore why. And it's going to become a biped. It's just going to have its 2 feet. And its hands are going to be free. Oh, this is us. I'm going to end today with the beginning of next week's class, which is the ascent of humanity, taking us up to the beginning of civilization. And you're going to meet some people who are very important in helping us to understand the story of evolution, Charles Darwin and Alfred Russel Wallace. But let's end with the oldest rock in the world, the oldest weapon. It's not this, but it's like this. The rock. See, when we tell the story of life on Earth, we say the story is in the rocks. The story is in the rocks, the layers of the rocks, like the rings of a tree. You go down the layers and you see all these different things happening. Well, about 3 million years ago, a human did this. That's 3 million years old. That's a rock. Oldest weapon we know of. And look at what an early human has done. This is us, the beginning of us, proto-humans. We will explore next week why we might do this. Some are going to say invention is the mother of necessity. Jared Diamond, Guns, Germs, and Steel, collapse. Others will tell you that no, it's not necessity is the mother of invention. It's the other way around. It's invention is the mother of necessity. Why would a human, with its opposable thumbs, its special precision grip, go look at a gorilla or a chimpanzee or a monkey in the zoo, you won't see this. We humans start to evolve. The thumbs gives us the precision grip. That's what it's called. You take a rock. Now, if you were a believer in necessity is the mother of invention, you're going to say, oh, well, we humans, this human who took this rock and sharpened it. I mean, it was doing that so it could kill something else, so it could survive. Maybe. But I wonder if once upon a time when Steve Jobs and Steve Wozniak were sitting in their garage in California inventing Apple computer, that they were thinking, well, we've got to do this with the computer and that, and we've got to solve everything. Or were they also just playing around, just having a good time in the garage, these techies, and figuring out how do you do this? Maybe a human took the rock and just started messing around. Gradually sees a large creature. This is sharp. Maybe I'll go kill it. And eventually we start to get things. Humans are going to take all this stuff around the planet and they're going to reshape it. It starts 3 million years ago. And it starts with the Great Divergence. When we diverged from our other ancestors in the trees, we diverged, we mutated, we came down. And when we came down and we stood, watch what's going to happen on this planet. I'm going to stop there. At least I've got you to the content, but I'm way behind on activity. Next week, I'll make it up to you and we'll start the activity earlier. There's just so much content that I want to get, and I haven't even told you half of it. But anyways, why don't we just stop for a second? Make sure if you have any questions, I can address those or anything you'd like to address, and then we'll just end the class, okay? Because we're essentially 5 minutes away to the end. There's no point starting an activity now. Do any of you have a question like, yeah, Lon, this is all great, and the next party I'm at, and I have a few drinks or something else, I can impress somebody with my knowledge, but so what? Why does this matter? Like, why are you? I came to this course to learn about the wars and about other things in history. I wasn't expecting to get this big and this cosmic and this. Does anyone wonder why this is relevant to you? And it's okay if you ask. Why is this all relevant? We've just covered very briefly 13 billion years. It started with gases, talked about the sun, the earth. You've looked at these weird creatures that have been evolving naturally. Now we end with a rock that's been shaped into a weapon by this early, ape-like thing. So what? Well, I'm going to suggest, as you leave today, that you remember something that I did say last week, I think, because I say this all the time, but I will say it again. The larger the island of knowledge, the larger the shoreline of wonder. Maybe you will leave here and begin to think, wow, if it's really like this, and I'm part of this, this is awesome. Like, this is, whoa, I'm part of something wondrous. Maybe we shouldn't kill any of it. Maybe we should nurture it. Why would we ever want to kill these things? Wait till you see when humans form civilization and societies and they decide that they think they know what to do, that their race is superior, that the Asian and the Sikh and the Jew and the Muslim and the Christian, that they've got the way. Oh, it's going to be massive slaughter. Because we're not that smart yet. We haven't figured it out. Jacob Bernowski said it's going to take us a long time to deal with the fact that we really do know we're on a planet and we are part of nature, but we humans, it's just too much fear. We're not ready to accept that. Yes. Yes, that's right. A lot of oxygen. Love the way you're thinking. Absolutely. I don't know. The student had said, because he didn't have a microphone, that because we had more oxygen on the planet as a result of photosynthesis that led to larger creatures, what if we have less oxygen? Will we have smaller creatures? We'll see. But it's good that you're making those kinds of leaps and wondering. Yes. Yes.
To sharpen the rock, what if they were curious? What if they saw other things eating meat, right? And decided, maybe I want to eat this meat, but I need a way to get it first.
It's very possible. What I want to make sure you just at least think about, what's your name?
Marshall
Marshall, good. Collins, is it? Marshall
Monroe.
Okay. Monroe, right, sorry. I want you to at least get into your mind the idea that necessity, being the mother of invention, is not the only way. And there are certain cliches that we all come into history classes with. One of them is, history repeats itself. Everybody says this. No. There's nothing inevitable about the historical process. Humans make mistakes and they don't always learn, but they don't repeat themselves a lot of the time. And that's how we get progress. Or as somebody once said, history only rhymes, but everything changes. But sometimes you hear the rhyme of repetition. Please try to open yourself to the idea that invention may be the mother of necessity. And we will look more at that because we humans are restless inventors because we like to play around. We like to mess around, play our guitars and see what comes up. A song. But yes, necessity too. And then history does not always repeat itself. There's no law in the historical process that says everything repeats, because when you say that, you become so cynical. Anytime you say, oh, it just all repeats itself, then the next thing you say is, there's nothing we can do. It's just the way it is. That's defeatism. That's cynicism. That's ignorance. And the only darkness in the world, as Shakespeare said, is ignorance. I have no time for that kind of ignorance. I truly believe that the human potential is unlimited if we can just get beyond our ignorance. I'll try and help you. I'm sorry about the screens, but Ron's been on the notes, and I must tell you something, to be able to walk in here at the end of this class, and it doesn't look like any of you have disappeared into your machines. This gives me so much hope. You want to know more. You care about your future, and you don't want to be treated like children. You want the real story, the best we can make it. You're prepared to hear it. A lot of people aren't. So thank you for coming in person. And next week, we're going to go straight to the screens, okay? And we'll do the tribal myths, the creation myths, and we'll decide on which ones, Iroquois or Christian or Buddhist, and figure out what they have said about our origins. And then we're going to move on and get into civilization. And that's when the crap hits the fan. Civilization. Okay, so everybody, thank you. And you can always email me if you have any questions. Do your discussion post for your 3. Ron gets his 3 just like that, just for doing. But go ahead and write anytime. And thank you, Xavier, Omari, Matthew, Ethan, Alexander, Aaron, and everybody else. Thanks, maybe. Don't forget to sign for your attendance. If you don't do your question, you still get 2 out of 3 just for being here. Just for being. If you want the full marks. I love you always. You're always thinking. I know how you think. I got to see your question. I got to see your question. Yeah. Good. What's your name? John. Okay. Way to go. Excellent. Thank you. Okay. Ron, I had something to tell you, but there's a few music students here. Are you music? Because I had something specific for you guys today. Inside the sun, it's actually